So about algebraic expansion and factorization. Well, to start here, we're going to have to make some examples here. And in these examples, A, B, C, D are all real numbers. So when you're doing algebraic expansion, in this case, you have 6 different methods. Method 1 is the distributive law, where you multiply A by B and C individually, and you get this result over here. Method 2, it's not really a method, it's really just showing that it doesn't matter where A is relative to the brackets. Method 3 is the product. The product is essentially multiplying A by C, A by D, B by C, and B by D, and you get this result over here. It's everything multiplied together. So method 4 is the difference of two squares. What you do here is you multiply A by A, which gets you the A squared, A by negative B, which gives you a negative AB, B by A, which gives you a positive AB, which cancels out with the negative AB, so this is why it's not here, and a positive B times negative B, which equals a negative B squared, because you're multiplying a positive with a negative, and this is why you get this result. Now method 5 is the perfect squares expansion. It's essentially the same as the difference of two squares, except there's no negative number, so you end up with an A squared and a B squared and 2AB because there's no negative AB to cancel out each other. And finally you have method 6, which is the perfect squares expansion but with a negative instead of a positive in here. What you do here is you multiply A by A, which gives you A squared. You multiply negative B by negative B, which gives you B squared because you're multiplying a negative with a negative, and then you end up with 2 a negative AB, or 2 negative AB, because you're multiplying a negative B with a positive A twice, which gives you this result over here. Now for factorization over here, you have method 1 backwards, which is basically what you're doing here is looking for a common factor between the two different parts of this equation, and then you simplify them by putting them into a bracket multiplied by the common factor. Next, you have the method 4 backwards, which is the difference of two squares factorization. What you're doing here is you're essentially splitting up these square roots into a times a and negative b times positive b, and you put them back into the brackets they came from. Now for method 5 backwards, which is called perfect squares factorization, you essentially just look for a and b and try and put them back into a plus b squared. The way you would do this usually is you would divide this part over here by 2 and then try and separate them to find out what a and b are. You can also take the square root of a and b to find out what the actual number is, and then separate all of this and eventually put it back into their brackets. For method 6 backwards, which is the perfect squares factorization with a negative, you essentially do the same, except there's one negative, so you're gonna have to take that into account, because essentially you have to find out which one is b, because you have to find out which one is the negative. Now for some further factorization, we're gonna take factorization expressions with 4 terms. What you're doing here is you're essentially looking for what these different terms have in common. So for example, this first part, AB plus AC has A in common, so you can put A here as a common term and BC in a bracket. Here you have D in common, so you're going to put B and C in their own bracket, and put D outside it. Now you notice that these two brackets are what A and D have in common, so these two brackets can be put together in one, and you end up with bracket B plus C times bracket A plus D. Now for factorizing quadratic trinomials, it gets a bit more complicated, because here you're going to have a single number x in the middle, and you're going to have a times b multiplied by each other. So what you're trying to find is what number is the sum of a plus b, which also is the product of a plus b, to find out what a and b is here. An example here would be x squared plus 11x plus 24. you'll notice that 3 times 8 equals 24, and 3 plus 8 equals 11, which means that 3 must be either A or B, and 8 must be either A or B, which leads to it being equal to x plus 3 in brackets times x plus 8 in brackets. So for the last part of factorization, you have factorization by splitting. There's no real way to show this other than with an example. So this example here is going to be 2x squared plus 11x plus 12. You'll notice that there's no two numbers which have the product of 12 and the sum of 11. So, but you also notice that instead of having 1x squared, this has 2x squared at the start. This is because the way you solve this is by multiplying this first term by the last term to find out what the product of these two are, which then leads you to be able to find out what the two numbers should be. So here you take 2 times 12 equals 24, and you can know from before that what has the product of 24 and also the sum of 11 is 3 plus 8. So you separate the 11 into 3 plus 8, and then you simply just do factorization like before. This turns into a factorization expression with 4 terms, which you then turn into this end result. So last but not least, you have Pascal's triangle. This is a triangle or a mathematical tool which you use to do binomial expansion way easier than normal. Now, if you're wondering what binomial expansion is, it is essentially what we did here with the perfect squares expansion. It's essentially where you have a bracket with a plus b, where a plus b, of course, can be anything, squared, or to the power of anything else. So the way the pattern is in this triangle is on the outside you will always have 1, and then as you every number below it will always have the sum of the two numbers right above it together. So for example, 2 is the sum of 1 plus 1, 3 here is the sum of 1 plus 2, and 6 is the sum of 3 plus 3. The way you read this is you essentially put a to the power of which level you're on. So this is the second degree for a plus b squared, which is the perfect square expansion. You'll notice that this is 1a squared b to the power of 0, which is essentially just 1a squared, or just a squared. And here you have 2a to the power of 1 b to the power of 1, which is just 2ab, and 1a to the power of 0 b to the power of 2, which is just b to the power of 2. You'll notice this this is the same as before, where it's just a squared and plus b squared plus 2ab. Here it's essentially the same thing, but for a plus b in brackets cubed. So here you have 1a cubed, you have 3a squared b, then you have 3a to the power of 1 b squared, and lastly you have 1a to the power of 0 and b squared cubed. And this is essentially how you write it down for every single degree. And so here, for example, you would have a plus b to the power of 6, and the way you do this is you would just do the same as up here. So you start with a to the power of 6, b to the power of 0, a to the power of 5, or 6a to the power of 5, b to the power of 1, which is just b, 15a to the power of 4, b to the power of 2, or just squared, 20a cubed b cubed, 15a squared b to the power of 4, 6a to the power of 1, b to the power of 5, and a to the power of 0 and b to the power of 6. And you would essentially just write all of these down in the order you please, because it's all addition, so the order doesn't really matter. But it's essentially how you can find any binomial degree you want.